We are discussing 11th standard, first unit, basic concepts of chemistry. In that lesson, in the previous class, we have discussed how to calculate the empirical formula of a compound given its, say, elemental analysis data. In continuation with that, let us try to calculate the molecular formula for a given compound, again given its elemental analysis data. Now, this question is given in your textbook as an evaluation question, question number 42. Calculate the empirical formula and the molecular formula of a compound containing 76.6 percentage carbon, 6.38 percentage hydrogen, and the rest oxygen. They have not given the percentage of oxygen directly, but they said that this compound contains oxygen. Okay. Now its vapor density is given as 47. Now based on the given data, we have to calculate the say empirical and molecular formula. Let us start. First, what we have to do, let us write the elements present. Here, say carbon is given, right? Carbon percentage 76.6. Then hydrogen is given 6.38. Okay, and the rest oxygen they are given. So oxygen is present, but we have to calculate the percentage of oxygen now. Now, how to calculate the percentage of oxygen? See, first of all, what we have to do, we have to add the percentage of carbon plus percentage of hydrogen, and that has to be separated from 100. So that is equal to 100 minus percentage of carbon will be 76.6 and that of hydrogen will be say 6.38. Now when you add these two, so 100 minus, you see 76.6, 6.38. So 8, 9, 82.98. So we have to subtract. So the subtracted value will come around, say 17.02. So this is the percentage of oxygen, and therefore I am writing it as 17.02. Okay, okay, the same thing what we have discussed in the previous class. So you should understand the tabular column. You have to by heart. The contents present are element, percentage, atomic mass, and the fourth column will be relative number of moles. Fifth one will be the simplest ratio, and the last again is a simplest ratio, but it should be in whole number. Now you know the atomic mass for carbon, that is equal to 12. Then for hydrogen it is 1, we know. For oxygen the value is 16. How to calculate the relative number of moles? We have learnt already that the say percentage 76.6 divided by say atomic mass. So the percentage you have to divide it by the atomic mass so that you will get relative number of moles. Likewise, 6.38 divided by 1 and 17.02 divided by 16. So this is the way that we have to calculate the relative number of moles. Now, when you divide say 76.6 by 12, the answer comes around say 6.38. I told you in the previous section that we can calculate the value either by direct division or you can perform log calculation. Only thing is that you have to get the answer right. 6.38 by 1 is equal to again 6.38. 17.02 by 16. For this the answer comes around say 1.063. Okay. So this value is completed. Now how to calculate the simplest ratio? So the simplest ratio can be calculated by dividing the relative number of moles. See 6.38 in the answer again 1.063 potash. In the answer take them write the same answer again. Now what you have to do here in addition, you have to write the smallest number here. Which is the smallest number? Say this 1.063 is the smallest number. So you have to divide this answer by the smallest number among these three. So the smallest number will be 1.06. So divided by say 1.06 divided by 1.063 say 1.063. So simplest ratio will be obtained by dividing the relative number of moles by the smallest number among the relative number of moles. Answer. So 6.38 divided by 1.06 that comes around say 6.01. Again this will be 6.01. This is 1. This is another simplest ratio. Simplest ratio in whole number you have to write. Now, the 6.01 I am 6 in it. That will be a whole number. Again, in 6 portfolio, in 1 portfolio. In a way, this is the whole number. Okay, wow. So now, how to write empirical formula? So empirical formula is equal to, we have learned already that we should write the element symbol. And as a subscript, we have to write this number 6. So C is 6. We write it in the subscript. C6. Again, H6 O1 and the O1 C6 H6O. Now this is actually the empirical formula. So till this step we have calculated in the previous session itself. Now in continuation with that, we have to perform for calculating the molecular formula. If a molecular formula first we have a formula, you see, it states like this. So N is equal to molecular mass by empirical formula mass. So what is this N? N is the whole number. Molecular formula, it is actually the whole number multiple of empirical formula. If the N is the whole number, we have to calculate now. You need to know the molecular mass. For that molecular mass, one data is given as vapor density. If vapor density terinja, it is easy that we can calculate the molecular mass based on some say a formula which you have learned in your 10th standard. In a formula, see, 2 into vapor density is equal to relative molecular mass. Am I right? So 2 into vapor density is equal to molecular mass or relative molecular mass. So 2 into given vapor density is how much? 47. So 2 into 47 will give you 94. So this you have to remember. So in the molecular mass cells, instead of giving vapor density, they themselves will give directly molecular mass. So in that case, you need not multiply. So here they have given vapor density and therefore we have multiplied it by 2 so that you have got now 94. That is actually the relative molecular mass or simply molecular mass. So this formula you have to remember. Fine. Now we are calculating empirical formula mass. So empirical formula mass is equal to, we know how to calculate. How many carbons here? 6 carbons. So 6 into 12. The 12 so 12 is the atomic mass of carbon, we know. Then 6 into, for hydrogen atomic mass is equal to 1. Plus 1 into, for oxygen atomic mass is equal to 16. Now that is equal to 72 plus 6 plus 16. So this will be 94. So the empirical formula mass is equal to 94. If anything wrong, you see, we write here. So N is equal to, just now we have learned this formula. So molecular mass by empirical formula mass. So N is equal to, molecular mass is equal to 94 divided by empirical formula mass. Just now what we have got is 94. So 94 divided by 94 is equal to 1. So the N value is equal to 1 here. Therefore, see, formula is like this. Molecular formula is equal to empirical formula into N. So that is equal to C6 H6O into 1. That is equal to C6 H6O. So in this sum, both say molecular formula as well as empirical formula is the same. You can see C6H6O is the empirical formula as well as the molecular formula is also C6H6O because the N value comes around 1. But it is not always the case in all the sums. In some sums what you can expect, this N value might differ. It might be 2 or it might be 3. In that case what you have to do? You have to multiply this by say 2 or 3. I hope you understood what I said. So in certain cases N value will not be equal to 1. So in that case you have to multiply that N value what you have got. If it is 2, multiply this by 2. If it is 3, multiply this by 3. In this case, in this sum, and since N value is equal to 1, we have got both empirical formula as well as molecular formula the same. Okay. So in this way, we can calculate the molecular formula for a given compound given its elemental analysis data. Thank you. Thanks for watching.